Hello everyone, welcome to today's class. We'll be starting with the new topic, that's differential equation. So today we are going to cover only the basic, that's the basic introduction of the topic. Okay, we'll see what kind of equations are called differential equation. Then we'll talk about two particular terms, order and degree. Okay, all right. So the idea is like you have seen a linear equation, okay, equation in one variables. You have seen like x plus 3 equal to 5. This is a equation in one variable. Okay, if I talk about equation in two variables, you will say x plus y is equal to 7. This is also an equation. If we look at any further, we'll say this is a quadratic equation, x square plus x plus 1, let's say something like this, equal to 4 or 3. Okay, these are all equations in x and y. So a differential equation will be also like this, pretty much same as this. It's just that it will be in terms of dy by dx, d square y by dx, and higher order derivatives. Okay, second order derivative, third order derivative, and third order derivative can also be there. Okay, so in general, a differential equation looks like this: dy by dx is equal to some gx. This is a simple idea, but this can be like d square y by dx square also, d cube y by dx cube also, something like that. Okay, then we have to understand two basic terms, and they're very relevant, and very simple question comes on this. Okay, as such, the first term is order. So what is order? Order of a differential equation is the order of highest order derivative. Okay, a lot of word order is there. Means your equation has dy by dx or d square y by dx square, d cube y by dx cube. Okay, that will define your order. Okay, means which order derivative is there, y dash is there, y double dash is there, y triple dash. What is that? dy by dx is there, d square y by dx square is there, or d cube y by dx cube is there. Which particular term is there, that will define your order. Whichever is the highest one, that will be your order. Suppose a equation involves d cube y by dx cube, so that will be your 3 will be your order. Then if it is d square y by dx square, that is the highest order derivative involved, then you'll say 2 is the order of the differential equation. Okay, all right. Then degree. Now degree is the highest power of the highest order derivative. Means after you finding which is the highest order derivative involved, you look at the power of that. Okay, let's take one example. Let's say if I write a equation dy by dx plus 3d square y by dx square, and there is a power 3 plus 5x is equal to 0, something like this. Okay, first of all, you'll have to find which is the highest order derivative. Means y dash is there, y double dash is there, clearly y double dash is there. Then we'll say order is 2. Then you have to look for its power. What is its power available, highest power? Okay, so that will be your this degree. Okay, it should be, remember that positive integral index means positive values only, and integral, it cannot be like 3 by 2. You cannot say a degree of a equation is 3 by 2, 4 by 7, no, or minus 2 also, you cannot say like that. Okay, all right. Now a very key point for degree, specifically I'm talking about degree, because order can be defined for any differential equation, degree may or may not be defined for any equation. So what is the condition for degree to be defined? So the key point is that the differential equation must be a polynomial equation in derivatives, means y dash, y double dash, y triple dash. A simple language, y dash, y triple dash should be a polynomial form. Polynomial form means you will have powers of y dash, y double dash, y double triple dash they cannot be having fractional power, they cannot be having negative power, they cannot be inside sine, cos, tan, or any trigo, any log, any exponential function. Okay, I'll mention this in the understanding point of view. Y dash, y double dash, y triple dash, and so on. Okay, can't have fractional or negative power, they can't be involved in trigo, log, exponential, or any kind of function. They should be independently present. They cannot be inside log. Okay. All right. Let's look at questions and let's try to understand these definitions with the help of the questions and examples. The first question, dy by dx minus cos x. Cos is there, fine, but inside x is there. We are not worried as long as it has x or y. Y can also be there. The problem is that y dash, y double dash, and y triple dash, and so on can't be with it, with the trigo or anything else. Okay, so dy by dx minus cos x. So fine. What is the highest order derivative? So you can see this is dy by dx. So order is 1. And what is the power available here? Power available is also 1. That's degree is 2. Order is 1. Degree is order is 1. Degree is also 1. Okay. Next question. Look at this. D square y by dx square is there. Dy by dx whole square is there. Okay. But what is the highest order derivative? D square by dx square means y double dash is there. Okay. 2 times differentiation. So that's your order. Order is 2. Before defining the degree, make sure that you have these conditions followed. Y dash, y double dash, they should not have fractional or negative power. They don't. So that means they are in a polynomial form. So yes, we can define degree for this also. What will be the degree? Power of this. What is the power? Nothing written means power is 1. Okay. Highest power precisely. But highest power of what? Highest order derivative, not this. Because as such, if you think dy by dx also has the power of 2. Okay. All right. Next is this. This is y triple dash. In case you are unable to see this, this is y triple dash. I'll rewrite this, y triple dash. Then y square plus e raised to power y dash. Okay. This is e raised to power y dash. Now, order. What is the highest order derivative? You'll say 3 times differentiation. That means order is 3. But degree, you can see this term e raised to power y dash is involved. Y dash cannot be involved with exponential, log, trigo, cannot be negative power or fractional power. So degree not defined. Okay. So it is a possibility that degree of a equation, differential equation, is not defined. Okay. Based on this, let's look at other questions also. We have to define order, degree, order, degree. What is the highest order derivative involved? D power 4 y by dx4. Okay. 4th order derivative. So order is clearly 4. Now point is this term y triple dash is inside sine. I told you this is not possible. That means degree is not defined. Okay. Next one, y dash plus 5y. So y dash, that means single order derivative. Okay. So order is 1. And what is there any term of y dash or y double dash with negative or fractional power or inside log, trigo? No. So degree is defined. So degree is 1. Third, what is the highest order derivative? Derivative we have to look for, means this, whether 1 time differentiation is there or 2 time differentiation is there. 2 time differentiation is present here. Okay, so clearly order is 2. What about degree? First of all, check whether degree is defined or not. This is ds by dt, d square s by dt square, ds by dt. Both have positive powers, no negative power, no fractional power. They are not present inside any function also. So yes, degree is defined. And what is the power available? No power, nothing mentioned means 1 as such. No? Okay. Nothing written means power is 1. Let it be. This again, d square y by dx square is there. This is dy by dx. So highest order derivative is clearly this one. So order is 2. And now, before looking at the highest power and saying that the degree is also 2 of this, no. Check this. dy by dx is present inside cos. I told you that y dash, y double dash, sorry, y dash, y double dash, y triple dash. Y can be inside cos, but y dash cannot be. So this cannot be inside, so degree is not defined. X can be present inside the trigo, log or anything. That's not a problem. This is okay. X is allowed, y is allowed. Y dash, y double dash, y triple dash, they are not allowed. What is the highest order derivative in this? This is power 2. Sorry, not power 2, d square y by dx square. So order is 2 and degree is clearly defined. And what is the power available of this? Power available is 1. Okay. Next, this one, y, this is triple dash, okay, y triple dash whole square, y double dash cube, y dash power 4, y raised to power 5. But what is the highest order derivative? Y triple dash. Okay, so order is 3. And are there any fractional powers or negative power involved with y dash, y double dash, y triple dash? No. No negative powers, no fractional powers. They are not inside any function also, no log, no trigo. So degree is defined. And what is the degree? Degree clearly here is 2. Okay. Same thing here also. Y triple dash, order is 3. What is the power? Nothing mentioned. That means degree is 1 here. This one again, e raised to power x is there. X is okay. E can be involved with x or y also. Okay. Y dash, the highest derivative, highest order derivative is y dash. That's order is 1. One time differentiation. Degree is defined and degree is also, what is the power? Power is also 1. 9th, y double dash, y dash whole square 2y. So highest order derivative again, y double dash, order is 2. Degree, whether it is defined or not, yes, again y dash, y double dash, both are present in powers. Okay, power 2, power 1, not a problem. Degree is defined. What is the power here of this y double dash? We have to look for the highest power of this, not this, not y dash. We have to look for y double dash highest power. That's 1. Here also y double dash 2 y dash sine y, sine is involved with y, it's okay. It cannot be involved with y dash, y double dash, y triple dash. So this is again okay. That means order, again order is highest order derivative, that's 1, 2, 2, and degree is also defined. What is the power available for this? 1. Okay. MCQ form, same idea. This is a differential equation. He's saying find the degree. Remember, degree cannot be found without order, but first check whether it is defined or not. You'll see this is okay, but dy by dx is present inside sine. I told you they cannot be inside that. That means degree is not defined. Whereas for the next one, 2x square d square y by dx square minus 3 dy by dx plus y. Highest order derivative is again 2, but is the degree defined? So dy by dx means y dash, y double dash, both have positive powers, so it's okay. So degree can be defined, not a problem. Order is 2, and what is its highest power? Its highest power available is 1. So degree is also 1. They have not asked, but still we have solved it. Now these were straightforward questions. Now let me give you some typical ones which will make you work slightly, not too much. Now my examples. I'll start with this d square y by dx square. Sorry, I'll write in y dash. Now it will be quicker like that. Y dash whole square plus 1 upon y dash is equal to 2. Okay. Now question is same. Okay, for all the parts that will be upcoming, you have to find order and degree. Okay, of DE is differential equation in short. All right, first question. If you rewrite this properly, it is y dash whole square plus y dash power minus 1 is equal to 2. I told you y dash, y double dash or anything cannot have negative powers. So as such, by looking at this, you might say, whatever is your understanding right now, you'll say degree not defined, right? But see, sometimes what we have to do is we have to manipulate the equation and get the new order and the degree. So let's manipulate this. If I take the LCM, it becomes y dash cube plus 1 upon y dash is equal to 2. This becomes y dash cube plus 1 is equal to 2y dash plus 1 is equal to 2y dash. Now if you look at this equation, forget about this, now look at this. Now can you tell me whether the degree is defined or not? Y dash, only y dash is there, so they both have both the y dash have positive powers, so that means it's not a problem, degree is defined. So now what's the order? Order is, what is the highest order derivative? That's 2, and you look for y dash is involved, sorry, y dash is involved, so order is 1. What is the highest power available? Here the power available is 1. Okay, this is, I'll write like this, 1. Here the power available is 3. So what is the highest power available? There, 3. So degree is 3, not defined. So these kinds of questions, they will confuse you. So I'm going to introduce these kinds of questions, okay, in which you might think the question degree is undefined, but if we manipulate the result, sometimes it is possible, sometimes it's not. Okay, so you have to see whether the manipulation is possible or not. Okay. Next one, 1 plus y dash whole square inside square root is equal to c y double dash power 3 by 2. Now again, if you look at the question directly, you will see I told you y dash, y double dash cannot be having negative or fractional power. So you might say that the degree is not defined. But let's again manipulate the result. This is square root, this is power 3 by 2. Let's square both sides. So this becomes 1 plus y dash whole square is equal to c y dash cube. Now is the y dash, y double dash have positive powers or not? Yes, they have. So degree is now defined. So what's your order? Highest order derivative, that's 2. What is the highest power of that? 3. So order 2, degree 3. Okay. Next, I'll take few, like 3-4 more examples like this, so you get comfortable with this. This one, cube root of y double dash is equal to square root of y dash. Now tell me, is it possible to see what is cube root? Again, coming back to the fundamental, Square root of x means x raised to power 1 by 2. Cube root of x means x raised to power 1 by 3. Now, if I rewrite this, even if I rewrite this, you'll say y dash power is 1 by 3. Y dash power is 1 by 2. So again, you might think fractional powers. This time the scoring will also not work. So what will you do? You'll say the degree is not defined. But wait, what can be done is I can raise both sides. I can raise power of 6 on both sides. If I can square both sides, I can cube both sides, I can raise any power both sides. So that becomes, if I raise power 6 on both sides, y dash power 1 by 3 into 6, power raised to power multiply na, and y dash raised to power 1 by 2 into 6. This becomes y double dash raised to power 2. This becomes y dash raised to power 3. Now both have the positive powers. Now is the degree defined? Yes. What is the highest order derivative? 2. What is its highest power available? Also 2. So for this question, order is 2, degree is also 2. Okay. This is done, this is done. Okay, let's have a look at this. It's a good example. 5 y dash double dash is equal to 1 plus y dash whole square power again 3 by 2. Okay. Again, just trying to confuse you with a lot of powers. First of all, right now power 3 by 2 means y dash is somehow inside a fractional power. It cannot be allowed. You cannot define degree based on that. So see if you can remove the fractional powers or not. So if I try to remove the fractional powers, so I have to raise the power both sides by 2. So squaring both sides. So this becomes 5 square is 25, y double dash whole square is equal to 1 plus y dash square raised to power 3 by 2 into 2, power raised to power multiply. So this is 25 y double dash square is equal to 1 plus y dash square power 3. Even if I open the cube of this, y dash cube, y dash squares cube, okay, even if I open it, still I'll get a positive power na? And order and degree will be defined based on this. So I don't have to literally open this a plus b whole cube. Order is highest order 2, degree is also 2. Order 2, degree 2. Okay, next, let's do this. Y minus y is equal to dy by dx, your y dash, plus a times square root of 1 plus y dash, something like that. Okay, clearly order, highest order derivative in all is y dash, that's 1, so that's not a problem. But you have to think for the degree. The degree is the confusing part. So point is, can I escape out of this square root? Even if I square it, a square plus b square, so this is your a, this is your b. Even if I square both the sides, a square will be generated, b square will be generated, fine, b square will cancel this square root. But what about 2ab? that will have these two terms in multiplication. So y dash will still be inside the square root. So will the degree be defined now or not? The degree can still be defined. It's just that before squaring you have to make sure that square root is unknown. So I am recreating this equation. Y minus x y dash is equal to a square root of 1 plus y dash. Now square both sides. So this is y square plus x square y dash square plus minus 2 into y into x into y dash, okay, minus 2ab, and then a square 1 plus y dash. And with this, now y dash has positive powers only. What is the highest order? Y dash. That's not a problem. Y dash is here, y dash is here, y dash is here. But what is the highest power? That's 2. Okay. So order is 1, degree is 2 for this question. All right. That is it about order and degree. Now let's talk about solution of differential equations also. Now if I talk about solution, what is the really meaning of this? So what was the real meaning of solution of this equation, x plus 3 is equal to 5? Means there was some value of x which we put here and it results into 5 when we add 3 9. Same idea. Suppose this is then dy by dx, or now the equation is said, let's say dy by dx plus x is equal to 0. Now something is there, okay, I'll take dy by dx square, dy by dx minus 2x is equal to 0. Now some y is there. After differentiating it, we get dy by dx, and when we put the value of dy by dx here, we get the result as 0. Okay. If you try to think logically, you might be able to pick what's your function. What is y? Y is x square, because then dy by dx will be 2x. If we put dy by dx as 2x, 2x minus 2x is 0. So that means this is the solution. Okay. But what if it was y equal to x square plus 3 or plus some constant c? Still we would have got dy by dx as 2x, and still this equation would be satisfied. So now you will have two kinds of solutions. One is called general solution, one is called particular solution. If you don't know the value of the arbitrary constant, that what constant was involved, what was the value, okay, you don't know its value, so that's why it's called arbitrary constants. If you don't know the value, it's called arbitrary constant, and if they are involved, the solution will be called general solution. If you know the value, means you know that y was actually x square plus 2, let's say, you know the value of arbitrary constant is 2, then you'll say that yes, that particular solution, the kind of solution this is will be particular solution. So this is the solution called general one, this one is called particular solution. Okay, general solution, particular solution. If you know all the constants value, if you don't know, they are called arbitrary constants. Okay. All right. Now one key aspect, number of arbitrary constants will be equal to order of differential equation, DE. I'm writing in short, but how many arbitrary constants are there will be depending on how many what is the order of your differential equation. Okay. Okay. Now the question says the number of arbitrary constants in general solution of a differential equation of fourth order. If the order is 4, that means number of arbitrary constants will also be 4. I told you this. Okay, we'll learn about this in more detailed manner in the next lecture when we'll talk about how to create differential equation. Then you'll have a much more clear understanding of this. Okay, right now take this as a standard rule. And the next question is saying the number of arbitrary constants in particular solution. The moment you say particular solution, I told you that in that, okay, this example was there, y equal to x square plus c and y equal to x square plus 2. So let's say the general solution was y equal to x square plus c, the particular solution was y equal to x square plus 2. There is no arbitrary constant here because it's a particular solution. Now whatever could be the order is 3. That means if we were talking about general solution, we would have said yes, the number of arbitrary constants will be 3. But if it is a particular solution, you will not have any arbitrary constants. Means you will know the value of constant. Arbitrary constant means you don't know the value of the constant. Okay, so in that scenario, you will not have any arbitrary constant a, b, c involved. You will be having a value. That means how many arbitrary constants are there in particular solution? 0. So this is true for general solution. Okay, general solution. Remember that. For particular solution, you have always arbitrary constants are equal to 0. You cannot define arbitrary constants in a particular solution. Otherwise, why will you call that as a particular solution if arbitrary constant c or a, b, c something is involved? Okay. All right. Let's see how to verify whether something was solution of a differential equation or not. Well, although I've given you the idea, what do? You have the y, you put the value of y. You need value of dy by dx also, d square y by dx square also. So let's generate first of all that. Let's generate y dash or dy by dx. That will be minus 3 into e raised to power minus 3x. Y double dash will be minus 3 again. So it will be 9 e raised to power minus 3x. Now let's put the value d square y by dx square. So that's 9 e raised to power minus 3x plus dy by dx, that's y dash minus 3 e raised to power minus 3x minus 6y. Y was e raised to power minus 3x. If we solve this, this is 9 minus, this all cancels out and it's 0. So yes, y equal to minus 3x is a solution. Okay, don't worry, you will not be asked these kinds of questions anyway, but this is just an idea to understand that what is the meaning of solution of differential equation. Means you put the value of the y in that equation, y dash also you calculate, you put that, y double dash also, and if they satisfy the equation, it's called your solution. It's like something you must have done in like grade 6th or 7th, something like this. Now x plus 2 equal to, let's say, sorry, what is the example I gave you? X plus 3 equal to 5. Na? So the teacher used to tell you that put x as 1 first of all. Put x as 1 and then check whether it is true or not. Then put x as 2, whether it's coming true or not. For this it is not. For this it is coming left side, right side equal. So you say yes, it's a solution. Same idea, just with differential equations. Okay. All right. That was the complete introduction for this differential equation. We'll continue in the next class. That's it for today. See you in the next class. Good day, everyone.